Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 19. This is translating graphs of functions. Classwork opening exercise says, graph each set of three functions in the same coordinate plane on your graphing calculator or a piece of graph paper, then explain what similarities and differences you see among the graph. Okay, so this is linear, f of x equals x. So remember, if we have f of x equals, or y equals mx plus b, then this is my slope, and this is my y-intercept. Okay, so 1x plus 0, well, that's going to be a point right here. So I'm going to go to my calculator over here, and I'm going to select a point. So this has a y-intercept of 0, so I'm going to put a point there. And then a slope of 1, which means go up 1 over 1, up 1 over 1, up 1 over 1, or down 1 over 1, and so on. Okay. The next function, g of x equals x plus 5, my y-intercept is 5, with the same slope of up 1 over 1, up 1 over 1, and so on. So these are the points. H of x equals x minus 6. The minus 6 is your y-intercept, and if you go up 1 over 1 or down 1 over 1, that is where they are going to be. So now if I go back to the calculator, all those points are entered, but if I input a function x, there it is, going through those sets of points. Okay, if I input the function x plus 5, there it is, going through all those points. So let me just drag this up here, and then finally, if I input x minus 6, x minus 6, and hit enter, and there you have it, all those lines went through those points that I just plotted. So now what we're going to do is explain what similarities and differences you see among these graphs. So the similarities I see here are lines with the same slope, and any line that has the same slope of another line, the lines are parallel, and they have a different y-intercept. So that's what we'll say. Okay, so for part A, the graphs are parallel lines, but they have different x and y intercepts. Okay, different y-intercepts and therefore different x-intercepts. That's true. Okay, so moving on to part B, let me clear this and we'll start B. Okay, everything's clear here. Now we're going to do part B. F of x equals x squared, g of x equals x squared, and plus 3, and h of x equals x squared plus 7. All right, so let's do, now this is a parabola. So let's switch to green this time. And since a parabola is, the constant is the y-intercept, the parent function is x squared. So if we plugged in 0, 0 squared is 0. So x is 0, y is 0. 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is 4. And 3 squared is 9. So let me move this up a little. Okay, and 3 squared is 9, and negative 3 squared is 9. All right, so now if I go back to my calculator and graph x squared, then the function went through all those points I just plotted. Okay, so now that is f of x, and there's f. Now we're going to plot g of x. So g of x is 0. If I plug in 0, 0 squared is 0, plus 3 is 3. 0, 3 is right here. So if I go back to point, 0, 3. And if I plug in 1, 1 squared is 1, plus 3 is 4. Negative 1 squared is 1, plus 3 is 4. And then 2 squared is 4, plus 3 is 7. Negative 2 squared is 4 plus 3 is 7. So now we have these points here. And then if I go back to my calculator and graph x squared plus 3 right here, x squared plus 3, then this purple function, g, is going through all those points I just plotted. Now we're going to do x squared minus 7. So you see what's going on here, I hope, by now. I'm going to switch to a pointer so I can move this up a little bit. And I need to go so I can see 7. There it is. So go back to point. So 0 squared is 0 minus 7 is negative 7. 1 squared is 1 minus 7 is negative 6. Negative 1 squared is 1 minus 7 is 6. See what I'm doing? Plug in 2. 2 squared is 4 minus 7 is negative 3. Negative 2 squared is 4, but then subtract 7, it brings it down to negative 3. 4 squared is 16, minus 7 is 9. Negative 4 squared is 16, minus 7 is 9. So then if I go back to my calculator and put x squared, cancel, go back to my calculator, x squared minus 7, enter, and then switch back to my move, and move, there it is. Okay, so there's my negative 7. All those points I just plotted, the lines, the function x squared is here, x squared plus 3, x squared minus 7 is here. So what's going on here? Well, they're all parabolas with the same rate of change, same a. They're all opening up. Their y-intercepts are different, and therefore their minimums are different. Okay, so let's bring that into verbiage. Okay, so here it is. Part B. The graphs look the same because they are congruent, but they have different vertices, which in this case means different minimum values. They are related by vertical translations. Okay. Okay, so here we go. Part C. Part C says f of x equals the absolute value of x. Absolute value functions are linear piecewise functions, where one side going down to the vertex, or the minimum or maximum point, is a constant function with a constant rate of change, same slope all the way to a certain point, and then a different slope from that point forward. Anyhow, absolute value just means distance from 0. So if I pick some points like we did before, and I plug it into my original function here, okay, right here, f of x equals the absolute value of x, well, think of plugging in a 0 there. How far is a 0 from 0? Well, the absolute value of 0 is 0. Okay, the absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3, and so on. The absolute value of negative 1 is 1. How far is negative 1 from 0? It's 1. How far is negative 2 from 0? 2. How far is negative 3 from 0? 3. How far is negative 4 from 0? 4. So you get the idea, and 4 is 4 units from 0 as well. So there's what it should look like. So if I go to my calculator and input absolute value of x, booyah, the function goes right through the points that I just plotted. So there's the parent function. Now it says g of x is absolute value of x plus 3. So if I plug in a 0, 0 plus 3 is 3. The absolute value of 3 is 3. So that means if I plot a point, plug in 0, I get 3. If I plug in 1, 1 plus 3 is 4. Absolute value of 4 is 4. Okay. 2 plus 3 is 5. Absolute value of 5 is 5. If I plug in a negative 1, negative 1 plus 3 is 2. Absolute value of 2 is 2. Plug in 0. 0 plus 3, oh, I'm sorry, we did 3, 0 already. Negative 2. Negative 2 plus 3 is 1. The absolute value of 1 is 1. Okay, -3. If x is -3, -3 plus 3 is 0. The absolute value of 0 is 0. All right, -4. -4 plus 3 is -1. The absolute value of -1 is 1. So here we go. -5 plus 3 is -2. Absolute value of -2 is +2. So now do you see what's going on here? And I go back to my calculator and check and do absolute value of x plus 3 and hit enter. And all those points I just plotted are right there on that blue function. Okay. Then finally x minus 4. So if I plug in, what makes that 0? 4 minus 4 is 0. So if I plug in 4, 4 minus 4 is 0. Absolute value of 0 is 0. Let me switch back to point here. 4, 0. If I plug in a 5, 5 minus 4 is 1. Absolute value of 1 is 1. If I plug in a 3, 3 minus 4 is -1. Absolute value of -1 is 1. And if I plug in a 2, 2 minus 4 is -2. Absolute value of -2 is 2. So there's a point right there. Plug in 1, 1 minus 4 is -3. Absolute value of -3 is 3. And I'll do one more. Plug in 0. 0 minus 4 is -4. Absolute value of -4 is 4. Now I go to my calculator and input this. Absolute value, x minus 4. Enter. So there you have it. Parent function. This blue one is g. See, it says g right there. So this is shifted left 3. So when I have a plus sign right here, it's moving the function left. -4 is right here. Okay, the x minus 4 absolute value is over here. So when I have a minus 4, that means to move the function to the right. Okay, so those are the 3 functions. So how are we going to say this verbally? Here's how we will. Okay, part C. The overall shapes of the graphs look the same because they are congruent, but they have different vertices. They are related by horizontal translations. The green one's the parent, the red one shifted right 4, the blue one is shifted left 3. Okay, page 2 brings us to the examples. For each graph, answer the following. What is the parent function? Okay, well, this is the parent function here going through the origin. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So this is just the simple parent function. So I'll do it in black. The black one is f of x equals x squared, and that is the parent function. How does the translated graph relate to the graph of the parent function? So the translated graph is the turquoise graph, if you will. Okay, I don't know if you'll be able to see that, though I'll just stay with blue. So this point right here is the point 1, 2, 3, 4. That's the point 4, 0. So it is shifted to the right 4, but then if I go over 1, up 1, I'm on the function just like I was here. If I go over 2, up 4, I'm on the function just like as I was there. So they are congruent functions, just one is shifted. So the translation g of x is a shift of x squared, and it's shifted to the right 4, so you have to say x minus 4 squared. I guess that should be an equal sign there. So x minus 4 squared. So if I plugged in 4, I'd get 0 squared is 0. So 4 is 0. If I plug in 1, I get -3 squared is 9. Go over to 1, it's up at 9. Right here. Okay? And then finally it says, so it's shifted 4 units to the right, and that's the function. Write the formula for the function depicted by the translated graph. So there it is. Okay, so all I didn't do is write down what it was. The graph is shifted 4 units right. So I'll say a shift of 4 units to the right. Okay, part B. This is the parent function, so I'll say f of x equals. Now, once you do several functions, you're going to get a feeling for what they are just by looking at them. So if I'm just looking at this and I say that looks like this function reflected across y equals x, so that's the inverse to x squared, and the inverse of squaring x is taking the square root of x. So I will check now. The square root of 0 is 0. The square root of 4 is 2, so there, that is right there. The square root of, I go to perfect squares, 9 is 3. And so those 3 points work, so that's the function. F of x equals the square root of x. That's the parent function. How does that translated graph relate to the graph of the parent function? Well, this is the same graph as this, except it shifted up 1, 2, 3, 4, 5. So a shift up 5 units. Okay, so it's a shift up 5 units. So what does a shift up 5 units look like? G of x equals the square root of x, and then plus 5 on the outside. That is a shift up 5. If the plus 5 was under the radical, that'd be the square root function shifted left 5. So be careful about that. The 5 is outside the square root. Anything outside is an up-down shift. Anything inside is a left-right. So there's that function and its parent. Okay, part C. Well, this is an absolute value function, so f of x equals, we just did it on the last page, absolute value of x. So absolute value of 0, 0, absolute value of 1, 1, absolute value of 2, 2, absolute value of negative 1, 1, absolute value of negative 2, positive 2. Okay, so this function is congruent to this function. It's just shifted over and down. So it's going to be g of x equals, so I now need to know, first I should say a shift, let's go left first, a shift left, and how many units? So we are here, this is 0, 0, so how about I do this? 0, comma 0 is my vertex, and this is the point negative 2, comma negative 3. So left-right shifts are your x, so I went from 0 to negative 2, so that's a shift left of 2 units. And a shift down (0 to negative 3 is a shift down 3 units. Okay, so a shift left 2, shift down 3. What's that going to look like in my function? Well, left and right are inside, go the opposite, so a shift left is plus 2, down 3 outside is the same sign, down is minus. So the function is g of x equals the absolute value of x plus 2 minus 3. Okay, page 3 brings us to the exercises. Starting with exercise 1, it says, for each of the following graphs, use the formula for the parent function f to write the formula of a translated function. Okay, so I've already done this parent function f of x, translated function g of x, and h of x for the part A and part B. Okay, so this is an absolute value function right here. Absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. So f of x equals, okay, absolute value of, here, let me erase that. I chose black and it just decided to write blue. Absolute value of x. So the parent function is the absolute value of x. The translated function g of x, and they give us the color coding here, that's the turquoise g of x up here. You need to be careful there. That is not shifted up 2, it's not shifted up 3, it looks like it's shifted up 2.5, and a shift up is an addition or subtraction. Up and down is outside, so g of x is the absolute value of x, and then it's shifted up, so it's plus, and it's shifted, the vertex is shifted up 2.5 or 2.5. I'll use a decimal. So g of x is the absolute value of x plus 2.5. And then finally, h of x in green is also a absolute value function that's congruent to the parent, but in this case it's shifted down 1, 2, 3, 4. So a shift down doesn't change what's inside the absolute value. Down is negative outside, and the distance is 4. So there's the 3 functions. Part B. See, this isn't so bad, is it? So part B, this one's a little harder to read. This is a function right here coming along, turning, and then going up here, and it's crossing at the point 0, 1. Okay. This is a cube root function. And cube root functions, so the cube root of 0 is 0, the cube root of 1 is 1, the cube root of 9 is 3, the cube root of negative 9 is negative 3. Okay, so this is the cube root of x. All right, so now translate function g of x. Let's see. Oh, I'm sorry. They didn't use, the parent is going through the origin. So let me just change that right there. So I should be looking at this red one. So the cube root of 0 is 0, the cubed root of 1 is 1, the cube root of 9 is 3, and the cube root of negative 9 is negative 3. Okay. So the parent was actually red in this case. So f of x, and they are labeled here, f of x is the red one. So let me just change this color to red. This is the quickest way to do it, I guess. Okay. All right, so now that's the parent function. Then we're going to do g of x, which is this one, going through the point 0, 1. So it's shifted up 1, and that one is blue, so I'll write it in blue. So it's a cube root of x. Shift up, down is outside, that stays the same. It's up 1, so it's outside plus 1. And then finally, h of x, the vertex, if you will, is right here, and that's negative 1, 2, 3, 4, 5, negative 5. It is a congruent to the other two. It's congruent to the other two, just shifted to the left 5. So I'll use purple for that, so it color codes. So it's the cube root of x, but inside you go the opposite direction. So for shifting left 5, it's going to be plus 5. Okay, I know that can be a little confusing, but if you put a negative 5 in here, negative 5 plus 5 is 0, and the cube root of 0 is 0. So at negative 5, we should be on the x-axis 0. So there's the 3 functions. Number 2. Below is a graph of a piecewise function. It looks linear here, and then it looks like a parabola, right side of a parabola with a negative a is what my guess would be. Okay, below, and it says whose domain is from negative 5 to positive 3. So that's as far as we're going. Okay, from here on the x-axis to here. Okay, that's what that domain thing means. Okay, sketch the graph of the given functions on the same coordinate plane. Label your graph correctly. So g of x equals f of x plus 3. So this is the function f. So they want you to shift it up 3. So the easiest way to do this, I'll use red for this piece, is go up 3 from each point on the corner of a grid. 1, 2, 3, so that'd be a point there. This is here. 1, 2, 3 would end up there. 1, 2, 3, whoops, right here. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So the red portion is right here. That is a shift up of 3. And then if I take this blue portion, this is shifted up 3. I should have gone a little further. 1, 2, 3. So this red line should actually come to here. And then the blue portion starts there. And then this is down 1, so this is down 1, but it's got a bit of a curve to it, so it'd look like this. Okay, and then here is the point 0. Go up 1, 2, 3 is right there, and then the end points down here count up 1, 2, 3, and it's right there. So this is a curve coming down like so. So that's a shift up 3. Okay, the next one says to shift it right 4. Okay, in parentheses, x minus 4 means to shift it right 4. Okay, so here's how I'm going to do this one just to show you. I'm going to draw this red segment here, and then I'm going to draw this, oops, try to follow this as closely as possible. It's really difficult with a pen stylus. Okay, there we go. So now if I take that and this piece and group them, now I can move the whole thing, and it's being shifted to the right 4. So I'm going to start right here. Whoops. Okay, so I'm going to, wow, struggling here. Alright, get my pointer. And click on this, and grab it here. So it started here. 1, 2, 3, 4. So there's the function shifted to the right 4. Okay, this is page 4, and it brings us to problem number 3, and it says match the correct equation and description of the function with the given graph. So here's 4 equations. Here are 4 descriptions. So I'm going to scroll this up so we can see all of them. Like so. There, that'll work. Okay, so I'm looking at these. They're all parabolas. Opening up, opening up, opening up, opening down. So looking for really easy ways to choose your solutions. There's only one down, and there's only one negative a. See this negative sign right here? That means E3 is the one that opens down. So the equation E3. Y equals negative, absolute, or negative, parentheses, x minus 3 quantity squared minus 2. So that is flipped over, shifted right 3, that's what this means, and down 2. Okay, so what did I just say? It's a reflection. Down 3, left 2? No, this was right 3, down 2. The graph of the function does not have an x-intercept. This is not crossing the x-axis. This is touching the x-axis. This is crossing in 2 places. So is that. This graph does not have an x-intercept. So that would be D2. Okay. Going on to this equation. So we've done that and we've done that. So this is a shift left 2, down 3. So parent would be here, left 2, down 3, no. Left 2, down 3, no. Left 2, down 3, yes. Okay. Left 2, down 3, so this is E4. Okay, so it's a shift right 2, down 3. I'm sorry, left 2, down 3 is E2. That's the one I was looking at. E2. This is E2. Left 2, down 3. The graph of the parent function is translated down 3 units and left 2. That is D1. Okay, so D1. Down 3, left 2. Down 3, left 2. There's my vertex. So that's D1. Okay, E1 is right 3. So it should be right on the x-axis, shifted right 3. And that's this one here, E1. Description. The coordinate of the y-intercept is 0, 1. No. The graph of the function has only one x-intercept. Yes. So it's D4. And then finally, this one has to be this, but we're still going to check. Right 2, down 3, 1, 2, 1, 2, 3. There's my vertex. So that is E4. And the description should be the y-intercept is 0, 1. Go over 0, up 1. There's my y-intercept. So D3 is also true. So there we go. E3, D2. E1, D4. E4, D3. And E2, D1. Okay, page 5 brings us to the end of lesson 19. Go do your problem set.